Hey guys, welcome back to my channel. Get creative, keep learning, keep growing. So before moving on to broadcast, let us move further into unicast routing, that is link state routing. So as you know that unicast means the transmission from a single sender to a single receiver. So it is a point-to-point communication between the sender and receiver. There are various unicast protocols such as TCP, HTTP, etc. So what is TCP? TCP is the most commonly used unicast protocol. It is connection oriented protocol that relies on acknowledgement from the receiver side. As you know that TCP is a reliable protocol, means for session initiation it established a connection, that is three-way handshake between the sender and the receiver, and after each and every packet is received an acknowledgement is sent by the receiver depending on the sliding window set. Now let's move on to what is HTTP. HTTP stands for the Hypertext Transfer Protocol. It is an object-oriented protocol for communication. So major protocols of unicast routing are distance vector routing, which we have seen in the last lecture. That is, distance vector router uses a distributed algorithm to compute their routing tables. Then the next one is a link state routing, which we are going to see here in this lecture. So link state routing uses link state routers to exchange messages that allows each router to learn the entire network topology. Now apart from this, there is one more algorithm, that is path vector routing. It is a routing protocol that maintains the path that is updated dynamically. Now without wasting time, let us move on towards the link state routing. So link state routing is the second family of routing protocol. While distance vector routers use a distributed algorithm to compute their routing tables, link state routing uses link state routers to exchange messages that allows each router to learn the entire network topology. So based on this learned topology, each router is then able to compute its routing table by using the shortest path computation. So link state routing is a technique in which each router shares the knowledge of its neighborhood with every other router, that is internet work. The three keys to understand the link state routing algorithm is knowledge about the neighborhood, flooding, and information sharing. So mostly the information sharing happens between the networks, between the routers in the networks. So first point is knowledge about the neighborhood. So instead of sending its routing table, the router sends the information about its neighborhood only. So in the distance vector routing algorithm, what we have seen that the complete routing table information is being shared. But here only the information related to the neighborhood is shared. So after a router broadcast its identities and cost of the directly attached link to the other routers. So whole table is not being shared. Only the identity and the cost associated with the neighborhood is shared. Now second point is flooding. So each router sends the information to every other router on the internet network except its neighbor. So this process is known as flooding. Every router that receives the packet sends the copies to all the neighbors. Finally, each and every router receives a copy of the same information. So only the information is not only shared to the neighbor but each and every one, every router in the network. So this is called as flooding. Since flood of messages are being shared among the routers, the step is called as flooding. Now third step is information sharing. The routers send the information to every other router only when the change occur in the information. Means what? If you compare it with the distance vector algorithm, what was happening there? Periodically the router table were updated. Means what? Even if there is no change, then updation occurs which inculcate an extra cost. But here in this link state routing algorithm, the information is shared only if there is a change in the information. So this is the major difference in the distance vector routing and link state routing. Now link state routing has two phases. First one is a reliable flooding initial state. Each node knows the cost of its neighbor. Final state, each node knows the entire graph. Now second phase is route calculation. Each node uses Dijkstra's algorithm on the graph to calculate the optimal routes to all the nodes. If you have studied data structure, then you must be knowing the Dijkstra's algorithm. Okay. So the Dijkstra's algorithm is used here to calculate the optimal routes to all nodes. So the link state routing algorithm is also known as Dijkstra's algorithm, which is used to find the shortest path from one node to every other node in the network. So what are the features of link state routing protocol? First one is a link state packet. That is a small packet that contains routing information. Then link state database, a collection of information gathered from the link state packet. Then shortest path first algorithm, that is Dijkstra's algorithm, that is a calculation performed on the database results in the shortest path. Let's say there are n number of node and there is a sender node and the receiver node, and there exists multiple paths from sender to receiver. Then this Dijkstra's algorithm will find out the shortest path between the sender and the receiver. Then next feature is routing table, that is a list of known paths and interfaces. Now what are the characteristics of link state protocol? It requires a large amount of memory. Then shortest path computation requires many CPU circulations. If a network uses little bandwidth, it quickly reacts to topology changes. All items in the database must be sent to neighbors to form link state packet. All neighbors must be trusted in the topology. Authentication mechanism can be used to avoid undesired adjacency and problems. No split horizon techniques are possible in link state routing and OSPF protocol. So one of the main characteristics of this link state protocol is OSPF protocol. So the protocols of link state routing are OSPF and ISIS. So OSPF is open shortest path first, and next is intermediate system to intermediate system. So here we are going to see OSPF, that is open shortest path first protocol. So let us move on to OSPF. So it is a link state routing protocol that is used to find the best path between the source and the destination router using its own shortest path first algorithm. A link state routing protocol is a protocol that uses the concept of triggered updates. That is, if there is a change observed in the learned routing table, then the updates are triggered only. Not like that the distance vector routing protocol, where the routing table is exchanged at a period of time. So open shortest path first is developed by the Internet Engineering Task Force, that is IETF, as one of the Interior Gateway Protocol, that is IGP, that is the protocol which aims at moving the packet within a large autonomous system or routing domain. So it is a network layer protocol that works on protocol number 89 and AD value 110. So OSPF uses multicast address, that is 224.0.0.5 for normal communication and 224.0.0.6 for updating to the designated router DR, that is backup designated router BDR. Now what is the criteria? To form a neighborship in OSPF, there is a criteria for both routers. It should be present in the same area. The router ID be unique. The subnet marks should be same. The dead timer should be the same. The stub flag must watch. Authentication must watch. So OSPF supports null, plain text, MD5 authentication. If you know the hashing technique, then you must be knowing the MD5 algorithm. Now note, both the routers neighbor should have some type of authentication enabled. That is, if one neighbor has MD5 authentication enabled, then the other should also have an MD5 authentication enabled. Okay. Now, what are the OSPF messages? OSPF uses certain messages for the communication between the router operating system OSPF. First one is a hello message. These are keep alive message used for neighbor discovery or recovery. They are exchanged every 10 seconds. This includes the following information: router ID, hello, dead interval, area ID, router priority, DR and BDR IP address, authentication data. Next is a database description. So next type of OSPF message is database description, that is DBD. So it is the OSPF root of the router. This contains the topology of AS or an area routing domain. Now link state request, when a router receives DBD, it compares it with its own DBD. If the DBD received has some more update than its own DBD, then LSR, that is link state route request, is being sent to its neighbor. Link state update, when the router receives LSR, that is link state request, it responds with a link state update message containing the detail requested. Link state acknowledgement, this provides reliability to the link state exchange processes. It is sent as the acknowledgement of LSU. Then link state advertisement. So it is an OSPF data packet that contains link state routing information shared only with the routers to which adjacency has been formed. Note, the link state advertisement and acknowledgement both are different messages. Timer, there are two type of timers, hello timers and dead timers. Hello timer, the interval in which the OSPF router sends a hello message to an interface. It is 10 seconds by default. And dead timer is the interval in which the neighbor will be declared dead if it is not able to send the hello packet. So it is 40 seconds by default. So it is usually 4 times the hello interval but can be configured manually according to the need. So OSPF provides, or advantages are, it supports both IPv4 and IPv6 routed protocols, load balancing with equal cost routes for same destination, VLSM and route summarization, unlimited hop counts is there. If you remember that RIP has some limited hop count, but OSPF has unlimited hop count. Trigger updates for fast convergence, a loop-free topology using SPF algorithm, run on most router classless protocols. So here are some disadvantages, like it requires an extra CPU process to run the SPF algorithm, requiring more RAM to store adjacency topology and being more complex to set up and hard to troubleshoot. So OSPF can be used in several types of networks such as point-to-point network, broadcast network, point-to-multipoint network, NBMA network, that is non-broadcast multiple access networks. Okay. So these are the certain types of networks where OSPF can be used. What is the configuration of OSPF? Configuring OSPF in network requires a basic understanding of OSPF concept and a knowledge of a network topology. So the following are the basic steps. So define the router ID first. Define the router ID for the router. This is an unique identifier for router in OSPF network. Then you have to configure the interfaces that will participate in OSPF. This involves enabling OSPF on the interface and defining the network type, whether it is a point-to-point network, broadcast network, or any other type of network. Then create a OSPF process and define the area to which the process belongs. Now define the router priority for each interface. So this is used to determine which router will be designated router and which router will be the backup designated router. Then enable OSPF authentication if desired. So it is a best practice to enable an OSPF authentication. It is used to secure OSPF communication between the routers. Verify the OSPF configuration and monitor the OSPF status. This can be done using show commands in the router's CLI. So OSPF is a powerful and widely used routing protocol that is used to determine the best path between the source and destination router. Its advantages are load balancing and fast convergence, make it a popular choice for large and complex networks. So if you want to understand what is OSPF, you should understand or have a solid knowledge of network topologies. So, but the end result is OSPF is a highly efficient and reliable routing protocol. So, our next topic will be broader gateway protocol that we will be seeing in our next video lecture. So, for now, thank you. Bye bye. Have a nice day.